Hello, how are you doing? This is Mike here, and in this video we're going to discuss something called the fundamental theorem of algebra. So this is the kit and caboodle of everything we've done so far in this class, and it might seem a little bit more scary just because it says fundamental and then it says theorem and then algebra all in one sentence, but it's really not that bad. First of all, let us go ahead and remember our definition. Remember the definition of a function. Well, maybe not a function. Let's say a polynomial. Let us say a polynomial, right? So we talked about a polynomial where we said that polynomial was equal to p sub x, a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, all the way down to our constant a naught. And we said that constant's a naught. Remember, this right here is the constant, and this right here is the important one. This one's the important one because this one is the leading term. Leading term. And we know that it is the most important one because it has the n value. That n value is the degree. And that is the largest exponent. So what the fundamental theorem states, the fundamental theorem states that the polynomial p sub x will have n zeros. Will have n zeros. It's going to have n zeros. Therefore, if you have a third degree polynomial, you're going to have 3 zeros. But remember, well, I don't know if I remember, I haven't really said it before, but you will have both real. Zeros can be both real and they can be imaginary. They can be real and they can be imaginary. So a lot of times, the way that we define the fundamental theorems, they say they're going to have n complex zeros, where the complex portion of the zero is existent for the imaginary portion, but then the complex portion is equal to 0 for the real portion. But I like just to remember that if you have an nth degree polynomial, you're going to have n zeros. So let's go ahead and look at some examples and see how we can evaluate this. Let us say that we have f of x equals to, let's say that x squared, my famous one, minus 5x plus 6. This right here, I'm so bad at drawing vertical lines. This right here is a graph that is going to look something like this. So it's going to look something like that. So here, he's going to intersect the x-axis there, and he's going to intersect the x-axis there. So we have 2 zeros. We have 2 zeros. And notice the degree of my polynomial is equal to 2. So we have 2 zeros, and my degree is equal to 2. Let us go ahead and examine maybe something else. Let us go ahead and examine a different polynomial. Let us say we have g sub x equaling to, let's just say, some x cubed plus a whole bunch more stuff. So I don't care what the rest of the stuff is. I just care of a possible polynomial. So in this circumstance, we could have a polynomial, but it's going to cross, it's going to go up, it's going to be that sigmoid looking thing, and it's going to come down, and it's going to go back up again. It could look something like this. So notice here in this circumstance, we have one, we have 2, and we have 3 zeros. So we have 3 zeros. And these are also intercepts and also solutions. They're also roots. So the degree of this polynomial is equal to 3, and we have 3 zeros. But then some of you might recollect some other circumstances that we had that were slightly different. So let me just go ahead and draw a picture. I could have done this the whole time. Let's say I draw this picture, and I have a parabola that opens up like this. And we have something that looks like this. This could be a potential parabola, and it's a quadratic. So we have a quadratic, and we know a quadratic has a degree of 2. We know a quadratic has a degree of 2, right? And since the quadratic has a degree of 2, we expect 2 zeros. And notice here, does this graph ever cross the x-axis? And no, he never crosses the x-axis. He is only positive. And it just so happens that in this circumstance, we don't have just 2 zeros. We have 2 special types of zeros that are complex, and they have imaginary values. So they're two imaginary zeros. So they are in the imaginary plane, which is a little bit more difficult for us to understand at this time. But just understand that we don't have two real zeros. We're going to have two imaginary zeros. So all the fundamental theorem of algebra states is that the degree of your polynomial is going to indicate how many zeros that you have. How many zeros that you have.